Hi. These are our plate tectonics notes. This is lesson 2, and these notes are yellow. I think everything for this unit is yellow, and we're going to talk about plate tectonics again, but we're going to talk about like how they came up with this theory. Okay, is it just a theory? Like, can people say that? Does plate tectonics not exist? Do you not believe in it? Um, I hope that you do because it is happening right now. Um, let's get into it. Okay, so how do we know that the Earth's crust is changing and moving? Um, all right, so people knew a really long time ago. I was kind of surprised when I saw that it was like the 1500s that the plates could move. Um, but you have to think like ancient cultures knew that they had earthquakes and volcanoes, so maybe they could figure it out from that. Um, they must have been extremely intelligent. Um, and then in the 19th century, we have records of people noticing that the continents fit together, right? And I'm sure you guys have all seen this. Al Gore talks about it in An Inconvenient Truth, but they do all fit together, right? South America could fit right in there with Africa, Australia, looks like it just broke off of Antarctica. Okay, so these do all look like they fit together because they did. So Alfred Wegener is the first guy that really kind of proposed this idea. Um, he said that the continents were slowly moving around the Earth. And he was a big explorer. He went to a lot of different places on Earth. So that's kind of what he was into. He was involved in like mapping and traveling. And he proposed this idea because he saw that there were similar rock types, geologic structures, and fossils on different continents. So, what that means is that they would find, like this guy right here, Sinognathus. They found it in this area right here, which really led to the idea, oh, well, maybe they did fit together. Or this guy right here, if they were found at the same place there, maybe they did fit together at one time. Okay, so he proposed this and it was a hypothesis, right? Um, and he was just saying that the continents were moving. He didn't say anything about how it happened or why it happened. Okay. Okay. So, how did we get from this kind of vague hypothesis? It wasn't vague, but we got from the hypothesis that Wegener came up with to this theory of plate tectonics that is very well supported and accepted presently. So, the first part we're going to talk about is seafloor spreading, which I'm sure you guys have heard about. This is so as soon as we had these new technologies from World War I and World War II, really, we had these new technologies like sonar. Um, we found out that we had these mid ocean ridges, and we had deep trenches, and we had this magnetic striping. Okay, so here's the mid ocean ridge. This is where we make new ocean floor. And what we are talking about is this striping here. Okay. So when this comes up, like the magma comes up, it cools off, and there is stuff in here that lines up with the Earth's magnetic field. Okay. So this is going to line up with how the magnetic field is right now. The green is when it's changed. The Earth's magnetic field flips back and forth um, every, like, I think I read 300,000 years. So that's what's happening here. We can tell it's very slow because we do see these, like, this is all that happened while the Earth's um, polarity was reversed, and then it switched back, and then it switched, and then it switched. Okay, but you do see this stripes on the ocean floor. And so that is really kind of how we understood this seafloor spreading. I have this cool video down here too. So you can see here we have make a new seafloor, and you can see, so this looks very uniform. This is probably more like what it actually looks like. So this is just showing that the polarity switches and the magnetic properties of this new rock that's formed. It takes on the properties of what the field is like when it forms. Okay. Then we also have subduction zones. This is also from seismic studies. And again, this is technology that came after World Wars I and II. So there were these subduction zones in the ocean. And what that means is that's where the crust goes back under the mantle. So we have crust coming here. Here is some continental crust, and here is some oceanic crust. Oceanic crust is more dense than continental, and so it goes down underneath. Okay, and so this crust right here goes down here, and it gets reabsorbed and melted into the mantle. You can see it happening right here too. So here's the crust, here's the trench, and it just goes straight down. It's always the oceanic that goes down when you have something like this, because it's more dense. So density just keeps coming back, right? And I'm going to play this video here quick. I think it's pretty quick. Yeah. So you can see this moving, all right? And this is creating some friction, which heats this up. So a lot of times you have volcanoes here, which we'll talk about later. But this is why we have trenches in the seafloor, like the Marianas Trench, which if you haven't heard of that, you should go look it up. So that's a subduction zone. So we have places where the seafloor is coming apart, and we have places where it is going under part of it. So it's like they're coming together, but part of it's going underneath. Okay. I think that's about it. Awesome. Okay, that is it. Wow, that was fast. All right, now you're going to do your assignment here. There is a little bit of mathy stuff. Please don't be intimidated by that. If you need help, that's what I'm here for. That's literally my job. And that's all. Yay!